بدينا. بسم الله الرحمن الرحيم. So as I said in the on the Moodle, our quiz will be delayed until Thursday. So in that case, this lecture Sunday and Tuesday we are going to continue the work on structures. Two birds with a single stone, عصفور بحجر. The first thing I found out, اكتشفت that you are not very تفضلنا, that you are not very familiar with structures. So I would like to talk more about structures. And second thing, so that I do not start the classes before your quiz, okay? So we're going to do the structures this lecture and on Tuesday. Then on Thursday we'll have a quiz that will not include those two lectures, okay? And we'll proceed as regular, يعني التطور الطبيعي. We'll have a lecture on structures, then our lab on structures, even though it is not on the quiz, but it is in the midterm and final. And 3. So the quiz you will have a tutorial tomorrow, okay? Regarding pointers, more example. We did a lot of problems on pointers in lecture, okay? But before the quiz, I would like to train you more on Monday's tutorial, okay? This is why I delayed the quiz until Thursday. So this tutorial on pointers was planned to be on Wednesday. طيب, we are going to continue about structures, and since last lecture was a week ago, so I'm going to quickly review what we said about the structures. Point 4 red. Quick review. We said that to use structures, we need first to define the type, then declare a variable, an object of structure type, then initialize this object, and finally we talked about arrays of struct, which simulate تحاكي mini databases, okay? Then I'm going to talk about today's main topic, which is pointers. Okay. So we talked about the structures, and the first step before using a structure is to define the type. Define the type. Because as I said, int or string or float are already predefined types that we are using, but there are no defined types for structures, so we call them user-defined. The programmer, it is the programmer who defines those types, so that we are able to use them later on. So it starts with the keyword struct, and then the name of the type, and this is the type we worked with last lecture, student record, and it is composed, it is structured مكون من several similar or different variables or fields, members of same type or different types, simple or structured themselves. فالstructure can contain anything. It can contain members of the same type. It can contain members of different types. The members can be simple or the members can be structured. So here, for example, we have two structured types, the strings, because they are arrays of characters, and one simple. But all of them are predefined. We can also have a structure within a structure. So a user-defined structure inside a structure. So this one has 3 members. It was 4 last lecture, but I updated it today. So it is 3 members, 2 structured, which are the strings. Yes. There are many semicolons here. There is a semicolon after each member, and there is a semicolon here that our Lamah friend found, Ali, that Majid found. What is this semicolon? Because the user-defined type definition is itself a statement, so it must end with a semicolon. So this is a statement that is defining a user-defined type, and this statement must end with a semicolon like any other statement in C++.
So,
yes.
A different structure within the structure or a variable within the structure? Same.
Inside?
Yes.
If you have a structure inside the structure, then you should define first the type.
So it's a new structure within the structure.
Maybe I did not understand your question. What is your question again?
The structure within the structure.
Not here. Here we don't have a structure inside the structure, but it is possible to have one. It is possible to have a new structure, struct, S2, that has inside student record an array of structure 10, and for example an int size. So this is an example of a structure inside a structure, but the inner structure was already defined before. Yes, it is user defined, but you should define before using it. There is, of course, one exception to this, but we'll not talk about it maybe in the data set. Next, we talked about the second step, which is variable declaration. As with any variable, we should declare it before using it, and at this step, you reserve space in memory. Reserve space in memory. And those are called variables of the structure type. Those are the variables. Or sometimes they're called instances. And I don't know why the inventor of programming languages like the human life, so the type itself, they call it like the ruh. And this is the jasad, the body itself. Maybe because they have this example in their culture. So at this time, we have a body, a real instance, hala, hayya, or jasad, from the previous type. In the previous slide, we did not have any storage in memory, just declaring, just defining a type. And it is in this slide, when we declare the variables, that we are reserving the space in memory, and we have the actual instances of this type. Because I cannot find the exact Arabic word translation for instance, so let us call it like this. Instance, like the tahqiq or type. And we talked about how do we initialize after defining the type, then declaring the variable, how we initialize those variables. So where is the definition? Here. So at this step, we have the definition. No memory reservation, no jasad, okay? And only inside the main where we have our two declarations, S1 and S2. So this is where we need space in memory. This is where we have the declarations. And then the final, this is like step number 1, step number 2, declarations, and initialization is the third step. Before using a variable, it should have an initial value, initialization. Okay? And we also use the comma separated list enclosed in braces, where the first item goes to the first field. Yes, the second goes to the second member, and third to the third member in the same order. We also talked about whole structure assignment. We can assign entire structures where the fields will be copied in the same order. So they must be of the same type. S1 and S2 should be of the same type. Otherwise, the assignment statement or the copy statement will not be valid. So this is, we call it copy constructor or copy statement, copy operator. And then finally, we showed you also how to deal with individual member access. Here I'm dealing with the entire structure, all the fields, or all the fields with an assignment. But how about if I just want to print the first field, Khalid, only? Then in that case, we use the dot operator. So we talked also about the dot operator. So now I just refreshed what we talked about, dot operator. So the dot operator accesses individual fields, but there is a mistake here, which shows that I did not run this code. Can you see the mistake? And you get 1 bonus point. There is a small mistake here I just found now. This code, if you run this code, it will not run.
S1 equals
S1 equals S2 works with structure, it can work. It assigns all the fields. Can anybody see it?
In capital.
Inshallah. So Majid, المرة دي صح? Found this Ramadan. Yeah, yes. So this N should be capital because, as we said, maybe in 100 or 101, C++ is case sensitive. Case sensitive. So this one should be N capital. And yeah, I did not run this code. Otherwise, I would find the mistake. The compiler will complain about it. And we also talked about arrays of structures. Like any arrays, we have arrays of int. Int A5 is a declaration. Int A5 is a declaration that reserves space in memory pointed to by the pointer A. So A is a pointer that points to the first element. And it has exactly 5 elements, all of the same type. All of them are ints. Okay? So in a similar way, we have type, name, and size. So this declaration, the declaration in here, declares an array, reserves in space 25 elements, each of which is of type student record, which is a string int string. Okay, so in that case, if I would like to access the field name in the element number I, then first I access the element number I using the dereferencing operator square brackets. The square brackets dereference the pointer students because students is a pointer to the first element in this array. With the square bracket, you dereference and then you reach the element number I. And then once you reach the element number I, this is how you access the individual field inside the element number I. And I think that was the last example in last lecture. So okay. We are declaring an array of type student record, which is still the same composition. The size is 3, so we have 3 elements. The first element is a string int string. The second one is string int string. The third one is string int string. This is how we initialize usually a normal array. We initialize an array like this, int a 3, 5, 2, 1, for example. Initializes an array so that it takes the element number 5, puts in the first one, 2 in the second, 1 in the third. So similarly here, I take the Ali123 CS and I put all of this in the first element of the array, which is students of 0. So in that case, I will put here the ALI, and I will put here the 1, 2, 3, and I will put here the CS. And similarly with the others. Okay? I try to choose short names so that it can fit. Yes.
بس عندنا السايز ما يصير
منين جبنا السايز؟
السايز موجود في ال
A is a different example. I was just showing you an example of how to declare an array in general. But here the name of the array is students. So here we have so these students of 0, these students of 1, these students of 2, and each one of which is a full structure that has 3 members, 3 members, 3 members. So if I would like to print, the whole student record, our mini database, then you will use a for loop to iterate through the elements of the array, elements. Students of 0, 1, and 2. This is how we iterate through the array. And then I will print name of student 0 is, name of student 0 is, colon, and then on the same line I will print students of 0 dot name. Students of 0 is the first one, dot name is the first member of the first element. So it is going to print is Ali, and so on. ID of student 0 is 1, 2, 3. Department of student 0 is CS. You will find this code, and this is what I will usually do. I usually put the codes on your on the Moodle, and so you will find the code, and you will also find the output of the code. Sometimes I put the output, so you'll find the output of the code on a separate sheet. Why do I put the code separately? If you have time, if you are interested, and you would like to test this code on your machine while you are studying, then it is easier to copy the text file code than copying from PDF file.
So,
Yes.
الفوق لعيب سطر سايد ده راح يقدر طبعا.
طيب. Haidar is asking a question. Many students in C or C++ are confused about the index. In C, the index is 0 based. We call the index 0 based. What does 0 based mean? It starts counting at 0. So, for example, here the size is 3. The 3 elements indices, the indices of the 3 elements are 0, 1, and 2. How many are those? 3. 0, 1, and 2 are 3, which is also fitting with this loop. I starts at 0 and finishes just before size. Less than size, not less than or equal. So 0, 1, and 2 are all less than 3. So this is still correct. In other languages where arrays are 1 based, then we start from I equals 1 until smaller than or equal to size. But because C is 0 based, we start at 0 and finish less than, strictly less than size. خلاص? Pointer to structure, like any other variable, we can have pointers that point to structures. For example, we had int, we could have something like this, int a, and we declare a pointer star p that points to int, and then we make this pointer, we assign to this pointer the address of a. This is something we did in the past. You remember? طيب. How do we declare a pointer? كيفية تعريف البوينتر؟ أيوه بالظبط كده. So we have the star. The star tells us that we have a pointer. Then the name of the pointer, p. Then what this pointer is pointing to. This pointer points to int. Okay, yes, it is an address in memory, but when I reach this address, what will I find in this address? What is the data that is stored there? An int. So this is what the int says. So here, similarly, we can see a star. Then we immediately know that this is a pointer, because a star in the declaration means a pointer. But when I reach the address, what do I find there? A structure, exactly. That is user-defined student record. So this declares a pointer to an object of type student record. Okay. Now, after declaring this pointer, p, how do I change the value in a by using the pointer? If I had a equals 5, if I want to change it, how do I do this? Star p equals 6. What does this statement at the bottom do? It dereferences the pointer. It follows the pointer until it reaches the memory, which is a. And then it overwrites تكتب فوق the number 6. Can I do this with pointer to struct? Yes, of course. But in pointers to struct, we also have fields. So this is how we do it. If we are pointing to a variable or a record of type student record, then to access the member name or ID using the pointer, then we need to first dereference the pointer, star pointer. Now we are following the pointer inside the memory. The pointer points to this area in memory that has name, ID, and department. So after I reach there with using the star, I follow the pointer inside the memory. Then once I am inside, I use the dot operator to access the fields. طيب. Why do I need those parentheses? Why do I need? أيوة. Yes, very good. Sheikha?
Yes.
Very good. Today, after the holiday, people are ready for a new start. صفحة بيضاء. البحوح؟
البحوح. البحوح آخر شيء ها. BH.
Okay, مكتوبة هنا مش عارف. Okay, so Sheikh also gets another bonus. طيب. So why do we have this? Because of the precedence. You said أولوية, which is the Arabic word for precedence. Precedence, أولوية الحسابات. the dot is stronger than, has precedence over the star. So without the parents, I will try to find the name field inside the pointer. But pointer is not a struct. Pointer is a pointer to struct. So there is no field inside pointer. There is an address. There are no fields at all. So we need first to dereference the pointer using the parents and the star. So I get inside, then inside I have those fields. Okay? Because you will find, when you use pointers with structs, you will find, so this is the answer, because the dot operator has higher precedence, أولوية أعلى, than the unary star. What is unary star? Yes, well, unary here means that, because what is star? Star is the multiplication, but multiplication operator is binary. It takes two operands. It takes two عاملين, the left and right operands. But here, this star is not the multiplication. It is the dereferencing operator. So it is a unary operator. It takes only one operand. Okay? لو شلنا الأقواس. What happens if we don't put the parentheses like this? Star, pointer, dot, name. Then because the dot operator has higher precedence than the star, the unary star, then this is how C++ understands it. And this is wrong. Because PTR is a pointer, it contains address. It does not contain the fields. It does not contain name, ID, department. Name, ID, and department after you follow the pointer and enter inside the memory. But the pointer itself does not have those fields. It will tell you name is not a member. If you try to compile without the parentheses, it will tell you, the compiler, name is not a member of pointer. Yes, name is not a member of pointer. Name is a member of star pointer. Star pointer على بعضها. All together. طيب. So this is how you access the members of a struct. You dereference, don't forget the parentheses, and then the dot. Because this is very difficult to write, and as I told you many times before, C++ is a shorthand language. You want to write with the fewest possible keystrokes باستخدام الكيبورد أقل ما يمكن. So they invented a new operator called the arrow operator. The arrow operator is composed from two operators, the minus and the greater than signs. Both of them together form what is called the arrow operator. Arrow operator does exactly the same thing. First, it dereferences the pointer. Second, it goes inside the pointer and get the member. Okay? So you don't need to type every time the parentheses and the star. And it is more natural to read. Okay, so in that case, this is how you write it. Pointer arrow name, pointer arrow ID, pointer arrow gender, and pointer arrow department. واضح؟ سهل؟ الغياب بس ما حدش يمسح البونص بقى الحقد والغل والحسد. بس أنا حافظها شيخ وعاد ماجد. Okay, so this is a simple example using structs with pointers. So to use a struct with a pointer, we need now 4 steps, not only 3 steps. First step is the definition of the type. Type definition. Type. No memory reservation. Very good. So this code has N capital and N capital. This code is available on Moodle and it is running correctly, inshallah. Second step is the declaration. and you reserve memory. Third step is the initialization. And because here we are using a pointer, so we declare the pointer, then assign the pointer. Assign the pointer. نؤشر بالpointer to this variable student1, which already has reserved space in memory. And then can I change the 1, 2, 3, 4, 5 inside the variable using the pointer? Yes, of course we can do that. So by using the pointer, you can indirectly modify ID, so it follows the pointer. Then with the arrow operator, it dereferences the pointer, so it enters inside the memory. Then it goes to the field ID. Yes, and then it changes the value to 6, 7, 8, 9. Okay, واضح? Okay, we will use pointers to. I will not give you a tutorial or a quiz on the structures, but you will find they are very similar to classes, and we will use pointers with classes. So this is why it is important to get this introduction. Okay. Don't forget to write your name in the sheet. Sorry, وصل فين؟ Okay. يلا سريع. And thank you very much, and I will see you on Tuesday.